Hi, I'm Jared with Fun Science Demos. We are back for part 2 of our spinning top engineering series inspired by the awesome book, The Most Magnificent Thing by Ashley Spires. In part 1, we showed you how to engineer a spinning top, how a top has a main part or a body, an axis or a handle, and a point, where that body should be located, and the length of the handle. We looked at all of those things in our engineering process. And we played around and made different iterations or variations of the shape of the main body of our top. And today for part 2, we're going to focus on the handle or the axis. In part 1, we used wooden skewers or toothpicks. But for part 2, what if we change the axis material to try to make different materials work? So we started by gathering some materials. We have chopsticks, lollipops, a pencil, some brad fasteners, a few straws, Q-tips might work, a dropper pipette, some marbles, and some plastic drink stirrers. Now before we build, we need to brainstorm and blueprint some ideas. Something like a pencil, it's pretty easy to see that it has a point, and this could be the handle. Even the chopstick, you can see it's tapered at one end. This makes sense that this will be my point, this will be my handle or axis, and the body will be attached lower. But when we get into some other things, well, we got to think it through a little bit. When we get to something like our plastic stir sticks, they look like they would work. The little round bulb part could be the spinning part, but there's a little plastic nib that I'm going to have to trim off, so I'm going to have to modify some of these materials. When I think about a lollipop, let's unwrap this thing, and it almost kind of looks like a spinning top. I have my weight down at the bottom, a nice round point to spin. Kind of spins, but it's very unstable, so I think I can make that work. Q-tip, one side, either side could be the spinning point. And when I get to a marble, I think the marble will spin, but I need to have a handle or an axis. The same thing with the little brad fastener. That brad fastener, that could be my spinning point, but I definitely need a handle or an axis to extend it. And then the dropper pipette. I have a tapered side, and you might think, wow, I could use that as my spinning point, but what if I flip this upside down? I have a nice rounded point, and the weight seems to be down here. I wonder if that makes more sense to use it this direction for my spinning top. A lot of brainstorming and blueprinting to think about, but I think we need to start by building a prototype and go from there. So we're going to start building our prototype, and we decided to start with the plastic stir stick. And if you look carefully, you'll find that this is not a rounded axis or handle, it's actually square. And we're thinking that's going to help with the friction of holding the main top body. We just drew a simple circle and cut it out of cardboard. And we notice that at the end, we have a little round spot that should be my point. I am going to take a scissors and try to trim off. There's just a little bit of plastic at the edge to make it a little smoother. And this should go on pretty easily. Slide it in all the way down. I'm going to try and keep it as low as I can. That's pretty low. The nice thing about this square handle is I can adjust it, and I have a pretty good friction fit. Now, so we can see how quickly this circle spins because it's a white circle. Actually, let me flip this over so you can have a better chance of seeing our top spin. I'm going to put a little mark so we can gauge how quickly our top spins. So we have our new axis. Let's put it right about there. Now, if you remember from part 1, we did add some weight. So let's try adding some weight to see if this will stabilize. So we've added some weight with our binder clips. It's a little bit better. Let's try flipping these handles in. The one thing I noticed by the force from putting all the weight has kind of made my axis, you can see it, it's loose. So I have to tighten this up. How are we going to do that? We're going to wrap some tape around the top part of our axis, the bottom part, just to see if we can sandwich it in there. So we've added some tape above and below to sturdy it up. We have a working spinning top using a different axis or handle. A plastic stir stick seems to work perfectly, and this kind of gives me an idea for our next iteration or variation. We have a round point. What if I use a marble and glue a marble to a straw to see if we can make a different type of axis? Let's give it a go. So our plastic stir stick has given us an idea to glue. We used hot glue a marble to a straw. We picked a thicker straw We're going to zoom in so you can really see our new axis design. So we've zoomed in so you can take a closer look at our new design for our axis. Again, we were inspired by the plastic stir stick. We have our marble glued to the stem of our straw. Now, the nice thing about this is we can trim the length of our straw to make our handle shorter, because part one, we learned a shorter handle gives us a better, more stable spin. Let's give this thing a go. So we have assembled the round circle of our body of our spinning top. I have it down pretty far just to give it a spin. Got some weight on it, got some tape on it. We'll trim the handle after our first test run here. Woo! It is spinning beautifully. I wonder what happens if we trim the handle. It's spinning so well. Let's take it down a little bit here. Give it a good spin. And a beautiful spinning top. Our next iteration works beautifully. So far we were able to get our prototype spinning well, and our first iteration maybe even spinning better. What if we try to step it up and try something more challenging for a handle or an axis? Next, we're going to try to make a lollipop work, and we picked the type of lollipop that has a big candy part with a nice handle or stem. Just out of curiosity, let's see how it spins. It kind of spins, but then it wobbles and falls over. So we need some kind of body to go with our spinning top to give it more substance and more weight. So what if we try to make this cup work? Let's start by finding the center of the bottom, punch a hole, and maybe we're gonna put some slits into our cup so we can fan it out and kind of make it like an opening skirt to give our spinning top a little bit of pizzazz. So now all I'm going to do is take a scissors and find the straight edge where the sides of the cup kind of overlap. Use that as a guide to make my first cut. And I want my cuts to be pretty thin. Just going to estimate an eye as I rotate around the cup. And what this is going to allow me to do is kind of fan these out and make a wider body for my top. So just use my fingers to fan them out, spread them out. That's going to be my top body. Now I have to attach the body to the axis. So we've done some problem solving. We've added some duct tape to the collar, and then we've added some right underneath. Let's spread this out. See if we can make a spinning top out of a lollipop. Yes, we have something that works. Now, if we wanted to, we could actually try adding some weight to some of these little fins with some paper clips, just to see how it spins. Let's give it a test and see what happens. We'll just slip some paper clips over some of these fins. We want to try and keep it balanced. So if I'm going to put one there, I'm going to want to put one opposite that one. So to add some more weight, we just slipped some paper clips onto each fin, added some weight, give it a spin. It seems to be much more stable, has more momentum. I think that's a good call. Let's try a couple more iterations. For another idea for an axis, we're going to think about using a dropper pipette with the bulb end as our point, the tapered end as our handle. We're going to use a thicker paper plate. You can see I've already traced it out, tried to find the center. We're going to push this through. It's nice and snug, just like we want it. Now the nice thing about this is we could actually add water to weight down the base and trim this up. So let's do that. So we've trimmed the top part of our dropper pipette to lower the handle height. We've taped the collar, and we've added some water into the base for some weight. Let's give it a spin. We have a spinning top out of a dropper pipette. We wanted to try one more thing for our axis, and that would be these brass paper fasteners. But the problem with this is they're too short. We need to add a handle. So we're thinking that one of these plastic coffee stirrers should be just the right width. Now it's a little loose, so we are going to have to attach that either with some tape or some hot glue, but I think we're going to use some tape. So you can see we've trimmed down the length of our handle, our coffee stir stick. We have a little bit of space. We added some tape. Now let's see if she spins. We have another beautifully spinning top with a completely different handle or axis. This is exactly what engineers do. They make different versions or iterations of the things they're trying to build. We started with a plastic stir stick, made our own marble and straw spinning top. We have a lollipop spinning top, a paper fastener spinning top, a dropper pipette, all engineered, designed, and built because we tried to make something better. A huge shout out goes out to Ashley Spires and her incredible book, The Most Magnificent Thing, for inspiring our part 2 of our Spinning Top Engineering Challenge series. We added a new axis and a new handle, and it worked out really, really well. If you want to learn more about science or engineering, check out our YouTube channel, Fun Science Demos. Science is so cool, especially when you get to do some engineering. Thanks for watching.